Okay, girls, today we're going to talk about proportions. We're going to be reviewing some things that maybe you've talked about in past classes, maybe algebra or 8th grade math, and applying it to geometry, which is going to be new. So we have some properties of proportions. A over B is equal to C over D is the same as AD equal to BC, which is called a cross product. That's the cross product property. Some people call that cross multiplying. It depends on who your teacher is. We'll call it cross products. That's what our book uses, and so that'll be, and that's also what your Regents exam uses, so that we'll use it to keep you familiar with the vocabulary. You can also switch these both upside down to equal BA equal to DC. So we just flipped both of the fractions upside down, and that's still the same. A over C is equal to B over D. That's going straight across, A over C, B over D. Or you can add B and D to both sides in order to get a congruent statement. So we add B, which is the denominator here, or you can add D, the denominator there. So these are some properties that you'll need to memorize. You need to know all of those properties in order to solve the problems that we'll be looking at later on in the unit. We also have some vocabulary. A ratio, we hear ratios and proportions together a lot. They are actually different things. A ratio is just one fraction. So when you're talking about a ratio, you're just talking about one statement and expression. There's no equal sign. So it's a comparison of two quantities. You write them either A to B with the colon, A over B, or A to B in words. You can write them in any of those orders. Just make sure that when it asks for a ratio that you keep it in the correct order. So if it asks for the ratio of the longer side to the shorter side, make sure the longer side goes first. Okay, a proportion is what we're going to be using a lot of with similar triangles. So we're going to talk about proportions, which are two ratios that are equal to each other. So A over B equal to C over D, or A colon B equals C colon D. If you get something like this one, just go ahead and switch it right over to your fractions because that's going to be the more useful way to use it. The last thing we have is a scale, which compares a model's measurement to the actual measurement. So this is used with replicas, scale drawings, and all other kinds of things where you would have one thing smaller than the original, but still to scale. So we have, for our scale, the ratio is going to be the length of something in the drawing over the actual length, okay? So we're going to be using that later on. If you need to write any of this down, you can go ahead and pause the video and take some time to write it. The next thing we're going to look at are some examples. So these are some examples of proportions that we're going to go ahead and solve. So when we solve proportions, we do the cross products. So I'm going to multiply this across here to get 7 times x and make it equal to multiplying the other way, 12 times 5, which is 60. And a lot of times you are going to get fractions with these, and that's completely okay. So we're going to divide both sides by 7 to cancel that, and we'll get x equal to 60 over 7. We do want our answers reduced, so make sure you check and see if it can be reduced. You can do that in your head, or you can use your calculator. Remember, to switch a fraction to its reduced form, you press math, enter, enter to get a reduced fraction. So let's look at this one here as our second example. We're going to multiply 8 times y, and then we're going to multiply the other way. I'm going to do 4. Your parentheses here are so important. You have to make sure that you put parentheses around your top when you multiply. If there's two terms, so if we have a letter and a number, you need to put parentheses. Then we distribute, so 8y equals 4y plus 12. And then subtract 4y from both sides to get 4y equals 12. And so then y is equal to 3. Okay, so we cross multiply or find our cross product and then solve. These next two are going to have some quadratics, so we're going to have to do a little bit of factoring review. So we're going to go through this and do the same thing, x times x plus 13. That's crossing this way, and then I'm going to cross the other way, equals 30. Distribute like the other one, x squared plus 13x equals 30. Okay, and then we want to get, anytime we do quadratics, we want to get them equal to 0. So this would be x squared plus 13x minus 30 equals 0. So we want that equal to 0. Now we can factor. You want to do this anytime you see x squared. So we take the number on the end, which in this case is negative 30, and we start listing our factors of 30. So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we look at those and we circle the ones that could be added or subtracted to 13. So I could subtract 2 and 15, or I could add 3 and 10. Now we have to look at our signs. Those are very important. So if I did this one, remember I said I'd take 15 minus 2 to get 13, and I'd do 10 plus 3. So I'm going to put my little signs in there. And I want to know what multiplies to negative 30. If I look at this, negative 2 times 15 is going to give me negative 30. Positive 3 times positive 10 is going to give me positive 30. So I want to use, when I put my parentheses, x minus 2, x plus 15. So x could be equal to either 2 or negative 15. And that would be my final answer. And we get that by setting x minus 2 equal to 0 and x plus 15 equal to 0 individually. Number 4 is going to be very similar. We cross them, x times x plus 2. Again, that's going this way. And then negative 3 times x minus 2. And that's going the other way. So when I distribute, I get x squared plus 2x. And on this side, I'll get negative 3x plus 6. Be careful of your double negatives. If negative times negative is going to be positive 6. Now I treat this the same as the other one. I want to get it equal to 0. So I do plus 3x minus 6 to both sides. And I get x squared plus 5x minus 6 equals 0. And again, I look at my end term, which is negative 6, and I write it off to the side, and I write my factors. 1 and 6, and 2 and 3. To get 5, I'd have to do 6 minus 1. And for the other one, I'd have to do both positive. So I look and I say negative 1 times 6 is negative 6. 2 times 3 is positive 6, so that one's no good. So when I write it, I'll get x minus 1, x plus 6 equals 0. So my x's will be 1 and negative 6. And again, we get that by setting both sets of parentheses equal to 0 individually. Okay, so the next thing we're going to do is look at some ratios. We want to find the ratio of the longer side to the shorter side. Remember earlier when I talked about ratios, we said we want to make sure we're keeping the one in front of the 2 on the top of our fraction. Okay, so here our longer side is 72. So we're going to write 72 to 12 or 72 over 12. Again, you can use your calculator to reduce this using that math enter technique that we used in the last section. So if I reduce this, this is the same as 6 over 1 or 6 to 1. Either of these forms is an acceptable answer. You can write it either as a fraction or as a ratio with a colon. We'll do the same thing with this one. We want longer to shorter, which is the same as 90 over 75. Again, if we go to our calculator and math enter, we'll get 6 over 5 or 6 to 5. Again, either of these are sufficient answers. You can use either one. They are interchangeable. Okay. Next, we're going to complete some statements using our properties. Okay. So this is a ratio, and we're going to go ahead and combine our properties. So we're going to use first the cross product rule. So 6 times x would be equal to 5y. And that's using our cross product, 6x, 5y. Okay, the second one, y over x, is upside down, so this has been flipped over. So we're going to flip the other side over. So this would be equal to 6 over 5. This next one is using our fourth rule from the notes. So x over 5, we're going across, is equal to y over 6. Again, that's going across here. You go x to 5 and y to 6. And for the last one, we're using our fourth rule where you add the denominator to the top. So we'll do 5 plus 6 over 6, which is the same as 11 over 6. Okay, so again, we took this denominator and added it to the top just like they did on the other side. So follow your rules and just plug them in. Okay, they're using the rules that you had from the section that we just took notes on. The next thing we're going to talk about is similar polygons. Two polygons are similar if one of the following is true. All the corresponding angles are congruent, okay, or the corresponding sides are proportional, and we'll do some examples to show how to do this. So the first thing that we need to know is our similarity ratio, which is the ratio of the lengths of corresponding sides. The similarity ratio is just one fraction, okay? You don't need to write a proportion, just a fraction, one ratio. And this little sign here, this is an important sign. This is our similar sign. It means two shapes are similar. They're not the same. One is bigger than the other one, but they have the same type of shape. So let's look at some examples here. This top piece is going to be very similar to what we did with corresponding parts when we did our congruent triangles, okay? The only thing that is different is when we're finding corresponding pieces, we're using the ratios, okay, instead of just setting the pieces congruent to each other. The angles are still going to work the same way. The angles are still congruent, but the sides are proportional now. So I have A, B, C, D similar, remember that's that sign, similar to E, F, G, H. So this shape and this shape are very similar. This one's just a little bit smaller, but they're the same type of shape. One is just shrunk a little bit. So if I say measure of angle E, okay, I'm looking at this one right here, and I look at my similarity statement, and I see E as the first letter. So it's going to be corresponding to the measure of angle A, just like we did with corresponding pieces of triangles. So A and E are corresponding, so they're the same. So if I look at angle A, that's the same as 53 degrees. Okay, so we're using corresponding pieces. With my proportion, I can treat it the same way. AB is congruent or is proportional to EF, so these are on the same part, and I can check here first and first, so that's true. And then AD, which is first and last, is going to go with EH because that's first and last on the other side. So I'm looking at my piece that's in the same fraction and finding the one that corresponds. So AD was on the top, so EH goes on the bottom. And we're just looking at the order of that statement. For measure of angle B, that is second in my statement, so F is second in my other statement. So this is equal to measure angle F, and measure of angle F is 127 degrees. For my last one, I'm looking at FG. FG is in the middle, so it's going to be the same as BC, which is in the middle on the other side. So BC will go with that in your proportion. Notice that when you're writing these proportions, you always have one triangle on the top and the other triangle on the bottom. You don't mix different triangles between the top and bottom. Okay, so that's how we complete the statements for corresponding pieces. The next thing is we're going to determine if shapes are similar, yes or no. If they are, we're going to go ahead and write the similarity ratio for them. So for the first one, we have two triangles. The top one is 15, 12, and 18. The bottom one is 16, 20, and 24. So we're going to set up some ratios using corresponding pieces and then see if they are going to have the same ratio. So I'm going to use my angles to help me. So I know that FED is going 1 mark, 2 marks, 3 marks. So FED, triangle FED, is similar 2, F, E, D, 1, 2, 3. So A, B, C. Okay, so this is what we're trying to show. We want to know, question mark, are they similar? Yes or no? We're asking this question. So we have to compare the different pieces. So let's compare FE over AB. And again, that's using the first two and the first two. Then we're going to compare ED over BC. ED is this last two. And then FD over AC, first and last. So we're going to set up these three fractions and see, are they equal, yes or no? So FE over AB is going to be 20 over 15. And remember, we want to keep the same triangle on the top, otherwise they'll come up upside down and that'll confuse our problem. So ED is 16 over BC, which is 12. And then FD is 24 over AC, which is 18. So all of these look different, but I'm going to go ahead and use my calculator and reduce all of my fractions individually. So I'm going to put 20 over 15 in my calculator, math, enter, enter, and I get that to be reduced to 4 over 3. Then I look at the next one, 16 over 12, again, math, enter, enter, reduce it. You can, of course, reduce these in your head, but if you want to double check, your calculator is a good resource for you to use. And the last one, also 4 over 3. So since all the angles are congruent and we have proportional sides, the answer is yes. They are similar. And then it asks for the similarity ratio. This is your similarity ratio right here. If the answer is yes, they should all be the same, so you only have to write it once. So the ratio is 4 to 3. Okay, so you just compare. If it was not similar, we would get different fractions for each of these. Okay, so that's how we know if it's similar or not. Our last type of question is to find missing pieces. So here I have an example of two trapezoids, not isosceles trapezoids, and it says that LMNO is similar to QRST, and I want to set up a ratio to find x, and x is up here. So I want to compare some sides that already have numbers. So I'm going to use LM and QR, so I'm going to put LM on the top over, and we make sure they're corresponding. LM and QR, yep, they're corresponding, they're in both first, equals. And then I want to use ON because it corresponds to TS. So I'm setting up my proportion using corresponding sides. And again, LM and QR go together, and ON and TS go together. So we're going to use those two. The reason I use LM and QR is because they both have numbers. If I use SR and NM, this is a blank. I don't know what that side is. If I use OL and TQ, again, both of those are blank. We want to find one pair that has numbers for both of them, if possible. So when I plug this in, LM is 5 over QR, which is 6. And I set that equal to ON, which is 2 over X. And notice LM and ON are from the same picture. QR and TS are from the same picture. We want to make sure the top and bottom are using the same picture. So I cross multiply, I get 12 equals 5x. And when I divide, I get x equals 12 over 5. It's okay to get a fraction. You can also write it as a decimal if you'd like. You'll get a 2.4. So you can say or 2.4. Either of these is an acceptable answer. Okay, so we have 12 over 5 or 2.4 as our result. We can do the same thing with a side that is not labeled. So if I want to find SR, which is over here, we can maybe make him Y. I don't want to make him X because I already used X in this picture, so I'll make that side Y maybe. Okay? And to find SR, we're going to do the same type of idea. We're going to use LM over QR again because that had both of our nice numbers, equal to But this time, instead of LM and ON, I'm going to use LM and NM, because NM corresponds to SR. Okay, so LM was 5, QR 6, NM is 3.2, and SR is what I'm looking for. We'll make that Y. So I do my cross product, 6 times 3.2, which is 19.2, equals 5Y, and then divide by 5, and I get 3.84. Okay, and 3.84 is a fine answer. It doesn't reduce to a very nice fraction. If you did a fraction, it would be 96 over 25. So either of those are acceptable answers. The decimal is probably easier, but you can write it either way. Okay, so there's our examples of similar triangles and similar figures. If you have any questions, please go ahead and come after school or during a free period, and I can go ahead and answer any questions you have.